Numericals on compound microscope. A compound microscope with an objective of focal length 1 centimeter and eyepiece of focal length 2 centimeter has tube length of 20 centimeter. Calculate the magnifying power of microscope if final image formed at the near point of eye. We know that magnifying power is given by L upon FO times 1 plus D upon FE. Here we are given FO equal to 1 cm, FE equal to 2 cm, and L equal to 20 cm. We put these values. 20 divided by 1, 1 plus 25 divided by 2, because D equal to 25 centimeter. So this is 20 into 1 plus 12.5, that is 20 into 13.5, which is 270. Let's go to next question. You are given two converging lenses of focal length 1.25 centimeter and 5 centimeter to design a compound microscope. If it is desired to have a magnification of 30, then find out the separation between the objective and the eyepiece. Here again, we will make use of the formula m equal to L upon FO 1 plus D upon FE. We have to find out the value of L. So magnification is given as 30, L is to be found, and FO is 1.25. 1 plus D is 25 divided by FE is 5. It will become 30 equal to L upon 1.25, and this will be into 6, which will become L equal to 30 into 1.25 divided by 6, which is equal to 6.25 centimeter. Let's go to next question. An angular magnifying power of 30x is desired using an objective of focal length 1.25 centimeter and an eyepiece of focal length 5 centimeter. How will you set up the compound microscope for final image to be formed at least distance of distinct vision? So magnification of eyepiece ME equal to 1 plus D upon FE. So we put the values 1 plus 25 upon FE, and FE is 5, which gives 6. Now total magnification is 30. So MO into ME equal to 30, from where we get MO equal to 5. Now, since image formed by objective is real, so MO will be negative. So MO will be equal to V0 divided by U0, which must be minus 5, from where we get VO equal to minus 5 times UO. And we are given FO as 1.25. Now we can apply length formula 1 upon VO minus 1 upon UO equal to 1 upon FO. So we put the values. So 1 upon minus 5 UO minus 1 upon UO equal to 1 upon 1.25. So this will become minus 6 upon 5 times UO equal to 1 upon 1.25, which will give UO equal to minus 1.5 centimeter. Now, let's write other information. Now we have VO equal to minus 5 UO, and we have got UO as minus 1.5. So we put this value here. So it will become minus 5 into minus 1.5, that is 7.5 centimeter. So this is value of VO. And 1 upon VE minus 1 upon UE equal to 1 upon FE. So let's find out VE. 1 upon VE equal to 1 upon, sorry, not VE. We have to find out UE. So 1 upon UE will be equal to, we can set this to RHS. So 1 upon VE minus 1 upon FE. And image is formed at least distance of distinct vision. So we can write 1 upon UE equal to minus 1 upon 25. And focal length of eyepiece is given as 1 upon 5. Sorry, it is given as 5. So here it will become 1 upon 5. So if we simplify, it will become 25, 5. So minus 1, minus 5. This will become minus 6 by 25. So we have got UE as minus 25 by 6 centimeter. Separation between objective and eyepiece. So that will be equal to separation between objective and eyepiece is equal to modulus UE plus modulus VO. We have got UE as this minus 25 by 6. If we simplify it, it will be around 4.17 centimeter. So its modulus value we can write here 4.17, and plus VO. VO we have got as 7.5 here. So we write 7.5. So total will be equal to 11.67 centimeter. So this is our final answer. Thank you for watching.